the second part of matrices using CAS. In the previous video, you learnt that the button here, the one to the right of the 9 or the left of the book, is where you'll find the matrix template, so to speak. Now, most of the time we do just use a 2x2, but sometimes if we want to use a different size, for example, a 3x2, a 4x1, anything like that, we use this guy here, and we can change the numbers of rows and columns. Now, I need to use just a basic 2x2 for this example. I'm going to keep that there. Where's he gone? This program's a little temperamental here. All right, let's try and add a new document. Done. Now I'll try my matrix. Okay, that's better. Well, we went through addition and subtraction of matrices, how to create and store a matrix as a pronumeral, and scalar multiplication. I'm now going to go through matrix multiplication, which is multiplying one matrix by another matrix. I'm looking at page 21 if you're following in the textbook. I've got two matrices. I've got matrix A, which is 5, 3, 2, 6. So I'm going to pop that into the system. 5, tab, 3, tab, 2, tab, 6, tab. I'm going to allocate A to this matrix. So control, store, and label him A. Enter. So that's my 5, 3, 2, 6 matrix. And then I'm going to have a second matrix, which I'm going to call B. And it is a 1, 5, 3, 7 matrix. Again, control, store, and I'm going to call him B. Now, using this, I can then multiply the two matrices together if I wanted to. If I do that, I want to do that, I do A times B. Oops, I shouldn't have pressed the space, wrong button, I wanted enter. A times B gives me 14, 46, 20, 52. Now, if you've been watching through the PowerPoints, you'll actually see that I did this by hand and surprisingly got the same answer. But what if I was to multiply B times A? Now, normally if we multiplied 2 times 3 and then 3 times 2, we know either way that the answer is going to be 6. But in matrix multiplication, A times B does not equal B times A. I'm going to show you here. So B times A, enter. I get 15, 33, 29, and 51 because I've gone from multiplying 5 and 3 by 1 and 3 to 1 and 5 by 5 and 2. So I've got different elements in that first position, that A11 position already. So multiplying two matrices together is very straightforward. You just do A times B or B times A, depending on what you're after. The order of the matrices is important. So remembering that from 7.3 PowerPoints. Now moving on to powers of matrices. So I can do A times A. Oh, where are we? Let's type that in. So I can do A times A. I don't have to just multiply it by B. I'm going to times it by A. And I get 31, 33, 22, and 42. But if the question just said this particular matrix squared, I could either put the matrix in, hit the power button, and square it, or allocate a letter and square it. So I've gone A squared, and I press enter. I get exactly the same answer for A squared as I do for A times A. And if I press my button there, my matrix was 5, 3, 2, 6, I believe. Let me just scroll back up again. A was 5, 3, 2, 6. Great. Now, if I'm only going to put this in once, I don't have to always allocate a pronumeral. So I'm going to show you that if I did 5, 3, 2, 6, then press the squared button and press enter, I would end up with exactly the same answer as a times a and a squared. If I wanted the cube of this previous matrix, I'm going to cheat and just control C, which you can do, and then control V. So I've already created my matrix. Then I use this little hat over here, 2 below the control button, and I put it to the power of 3 and then hit enter. So it takes this solution and then times it by this matrix again. Now, looking at the order of these matrices, you'll notice that I started with a 2 by 2 matrix and I still have a 2 by 2 matrix. I'm going to pop in a 3 by 3 and see what happens. Keep it as 3 by 3 there, and I'm going to quickly do my elements with my keypad. I've got 5, 11, 12, 7, 3, 1, negative 4, 2, and 6. Now, if I was to put that to the power of 4, I would press my little hat button there, press the number 4, and press enter. It gives me 4,450 as the first number. I've still got the order 3 by 3. So I started with 3 rows and 3 columns. I've still got 3 rows and 3 columns. Question, how many rows and columns would I have if I had it to the power of 50? So I'm going to copy this rather than having to type it all again. I should have allocated a letter to it. I know this. It would have saved me some time. Oops, wrong one. Let's see if that works now. Yes, that's better. Now, if I was to put that to the power of, let's go to the power of 10. Numbers might be getting too big otherwise. Or the power of 12. It doesn't matter what power I put this to. You'll see that the columns and the rows still remain the same as what the original matrix was. So the order doesn't change regardless of the size of it. All right, I will be back for part 3, which will cover inverse matrices.